Hello and welcome to Unit 3, Lesson 1. This is Newton's first law of inertia with introduction to forces. We studied the subject of kinematics in Unit 2, and now we're turning our attention to a subject called dynamics. Dynamics is the study of the causes of motion. Now that you understand a little bit about what motion is and how to describe it, we now are going to look at what is actually causing motion. And the answer to that question is, of course, forces. Forces cause changes in motion, changes to velocity. What is a force? It's basically a push or a pull, or a better way to think of force is it's an interaction between two objects. Force is also a vector. That means force has a magnitude and direction, just like velocity and acceleration do. Forces cause objects to accelerate. They cause them to speed up, slow down, or change direction. Without forces, everything would just move at a constant velocity. There would be no change. The units of force are newtons. I'm going to explain to you what a newton is. What does that unit mean? Well, what a newton is, it's 1 unit of mass, or 1 kilogram, multiplied by 1 unit of acceleration, or 1 meter per second squared. But instead of saying kilogram meters per second squared all the time, we've just shortened it to newtons. We use a capital N to stand for newton. Here are some typical forces in newtons. Just to give you an idea of the size of newtons. Of course, we're used to the unit of pounds to describe force. We don't use newtons as much, but the weight of an apple is about 1 newton. A human weighs about 1,000 newtons, and a force to accelerate a car is 7,000 newtons. And you see all the way up to the main engines of a shuttle, 31 million newtons. And all the way down to the weight of an ant, which is 1/1000th of a newton. So there's a wide variety of forces. You're not expected to, of course, to know these numbers. It's just to give you a feel for what a newton is. So let's talk a little about mass. Sometimes people confuse mass with weight, but there really are two separate things. Mass means the measure of how difficult it is to change the velocity of an object. That is a definition of mass. Another way to think about mass is basically the amount of matter that an object has. Something that has a lot of mass, it's hard to move. It's hard to slow it down, speed it up. It's hard to stop it if it's already moving. And the more matter an object contains, the more mass it has. We've talked a little bit about the units of mass already. They're kilograms, abbreviated kg. Here's some typical masses. Again, from the very small, like a bacterium, 10 to the negative 15th kilograms, all the way up to the very large. The Earth is about 6 times 10 to the 24th kilograms. An average human adult has a mass of 70 kilograms. Again, just some numbers to look at. Now we get to Newton's first law of motion. Newton's laws of motion are critical to understand the basic concepts of physics. Isaac Newton, of course, we've talked about him before, was a famous physicist who came up with 3 simple laws that explain all motion we observe in our everyday world. And his first law states simply this, that an object at rest remains at rest as long as no net force is acting on it. An object moving with constant velocity continues to move with that velocity as long as no net force acts on it. So basically this law is talking about things being at rest will stay at rest, and things that are moving want to keep moving. Galileo actually coined the term law of inertia when he described this law. He was the first one to come up with this idea of inertia, which is a Greek word that means laziness. He basically said that objects are lazy. The more mass they have, the harder they are to get moving. Notice from this law that we can see that constant velocity is the same thing as being at rest. If you're sitting in the classroom or sitting in a chair, you are really actually moving at a constant velocity because the Earth is moving. That means you are moving. But we cannot really distinguish between being at rest or moving at a constant velocity. They both really are the same state. It's only when we are accelerated by a force that we notice a change in motion. We actually notice our motion. So here's the short form of Newton's first law. There's another way to say the same thing, but that is that if the net force, or F net, by the way, the net means total here, so if the total force equals 0, then the velocity of the object is constant. And there's a word we use for that. We mean equilibrium. So if something is in equilibrium, it has a constant velocity, and there is no net force acting on it. The total force acting on it equals 0. That's Newton's first law. Here's some examples of inertia. Here's Mr. Sarge taking a nap. You notice I'm at rest. There's no force acting on me, so my state of motion will not change. And here's a ball, and we're going to shoot the plastic piece out from under the ball, and you notice the ball stays in one place without a force acting on it. It will not move. Let's take a look at that second video again. Hold on a second. Let's watch that again. Notice that the ball is at rest. And when we apply a force, we apply a force to the plastic piece flies out, but the ball remains where it is. Let's back that up slowly and see what happens here. There it is. Let's advance it. You can see there's the plastic piece sliding out, but the ball stays where it is. That is inertia.